Alright, so I figured I would come up with one more difficult trig problem for us here to try, just in case you want to look at another video. So what we're going to do is we're going to take square root of 3 times the tangent cubed of theta minus tangent squared of theta minus the square root of 3 times tangent of theta plus 1 equals 0. Okay, just like I was telling you guys in class, the directions for something like this are going to be solve for all possible values between bracket 0 to 2 pi. Okay, so essentially any angle that's on the circle, you can solve for it here. Alright, so when I first look at this equation, what I see is that there are 4 terms here. Okay, 1, 2, 3, 4. Anytime that there's an even number of terms, what I'm going to try to do is I'm going to try to factor by grouping. Okay, so I'm going to jump straight into it here. I'm going to take these first 2 terms and these last 2 terms, and I'm going to try to factor by grouping. When I look at these first 2 terms, what I see is that I can take out a tangent squared of theta. Okay, and when I do that, I have a root 3 tangent of theta, because there were 3 and I took out 2, minus 1. And then for the last 2 terms, all I can do is take out a negative 1. So I'm going to flip the signs on everything. So I'll have root 3 tangent of theta minus 1. All of that is equal to 0. Okay. I have the same thing in both sets of parentheses. Even though it looks weird, it's the same thing. So I'll have root 3 tangent of theta minus 1 times tangent squared of theta minus 1 is all equal to 0. Okay, and we're getting to the end of our algebra part here. Okay, now I have a product that is equal to 0, one thing times another thing. So what I'm going to do is I'm going to take each one of these factors, set them equal to 0, and I'll solve. Okay, so there's my first statement. Second statement is tangent squared of theta minus 1 equals 0. Okay, if I take this first statement, I will add 1 and divide by the square root of 3. And then in my second statement, I'm going to add 1. And then I'm going to take the square root of both sides. And don't forget, when you take the square root of both sides, you'll have a plus or minus 1 out here in front of your square root. Okay? So, at this point, I'm done with the algebra. Okay? So say algebra, check. Okay, now I need to start thinking about this in terms of trigonometry. So let's split this into 2 sides, and let's look at these separately. Let's start out with a tangent of theta equals 1 divided by the square root of 3. Okay, first thing I'm going to decide here is what quadrants am I working with. Okay, well, tangent is the ratio O over A. Okay, and the 2 quadrants where when I divide the opposite side and the adjacent side, I'm going to get a positive answer are the first quadrant, and then also in the third quadrant. Okay, so my goal is now to figure out what are these little reference angles right here. Okay, and again, we've done this a bunch, but if you need to, draw them again. Here's a 30, 60, 90 triangle. Okay, and here is a 45, 45, 90 triangle. Okay, and if we're trying to find a tangent value of 1 over root 3, remember, that's opposite over adjacent. So if I look at the 30-degree angle right here, its opposite side is 1, and its adjacent side is square root of 3. Okay, which means these little angles right here are 30 degrees, or in other words, in radians, they would be pi over 6. Okay. So what I need for my final answer here is the angle in the first quadrant, that's a pi over 6, which is going to be pi over 6. And then the angle in the third quadrant, that's a pi over 6, which is going to be 7 pi over 6. Okay? So I've got my first factor solved. Okay, now I'll come over here, and I'm going to work with my second factor now. So if I look at my second factor, it says tangent of theta equals plus or minus 1. Okay, well, if tangent is plus or minus, the 2 quadrants where it's positive are the first quadrant in the third quadrant, and the two quadrants where tangent is negative is the second quadrant and the fourth quadrant. Okay, so in this case, I'm actually going to be working with all four of my quadrants. All right. If you come and take a look at these triangles that I drew on this slide right here, what you can see is the 45-degree angle has a tangent value of opposite 1 divided by adjacent 1, resulting in a tangent value of just 1. So, for my little reference angle here on all of these little angles right here, these are all going to be pi over 4. Okay? Because I'm working with all four quadrants, what I'm going to put for my final answer is all the angles on the circle in the first, second, third, and fourth quadrant that have an angle, that have a denominator of 4. Which for us, in the first quadrant will be pi over 4. The second quadrant will be 3 pi over 4. The third quadrant will be 5 pi over 4. And the fourth quadrant will be 7 pi over 4. Okay. So we took this weird polynomial equation at the beginning. We factored it by grouping. Okay. We took each factor when we had a product that was equal to 0. We set those equal to 0 and we solved to finish our algebra. Okay. Then we started switching gears to trying to figure out which theta values would make these true statements. Okay. For our first one, we figured out because tangent was positive, we would be in the first and the third quadrant, and the angle that has a tangent value of 1 over root 3 is 30 degrees, or pi over 6. So we needed the pi over 6 in the first quadrant and the third quadrant, okay, which were pi over 6 and 7 pi over 6. For this second statement, we got tangent was equal to a positive or a negative number. Tangent is positive in the first quadrant and the third quadrant, and it is negative in the second quadrant, the fourth quadrant. So in fact, we're actually working with all four quadrants. And the reference angle that has a tangent value of 1 is 45 degrees, or pi over 4. And because we're in all four quadrants, we take all four angles on the circle that are pi over 4s. So that would be pi over 4, 3 pi over 4, 5 pi over 4, and 7 pi over 4. And at this point, we're not only done with the algebra, but we are also done with the trigonometry as well.